sheets where we had done all the properties before, we've also done these properties, but it was with only square roots, not different roots. So now we've talked about third roots, fourth roots, fifth roots, and so on. So that's where these are going to come into play. Caleb, take your hat off. My goodness. All right, so the main properties we're going to be looking at are multiply and divide properties, where if you have, and I'm going to show it to you with square roots first. We did things like if you have the square root of 50,
25.
You could break it up. 25 times 2 is 50, and it can be split up this way. Okay? Because the property technically is the square root of AB is equal to the square root of A times the square root of B. In other words, if you're multiplying something under the radical, you can split it up into the two radicals being multiplied together. And we did that because it's handy if there's a perfect square that you can divide it by. The same goes with division. If you're dividing, you can also take that radical to the top and the bottom. And so I'm running through this kind of quick because those are old properties, but we're going to use them now with the roots that we're talking about. I'll give you all a second to. Let's look at splitting some up real quick, and then we'll put everything together. So before, when we had, like we said, 50, we did 25 and 2. And if you remember, I had you write your list of perfect squares off to the side. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36, and so on. And so we use this to see what the biggest thing we could divide 50 by was, right?
Yeah.
My question to you is, why did we use powers of 2?
Because we're square rooted.
Because we're square rooting. What's the imaginary number that sits right outside that little square root? 2. Right? So what if I changed it to the cubed root of...
Like on our test, it'll have a 3 right there.
16. Okay? That's the square root of 4. This time I'm looking for the biggest power of what? 3. Okay? So what I'm going to have to do is make a list of powers of 3 this time. 2 to the third is 8. 3 to the third is 27. I'm already too big. But Caleb says it's 8, and it is. I can split this up. 8 and 2. Okay?
But
So,
that's not 3.
what? 2 times 2 times 2
Gives you 8.
gives you 8. So the third root of 8 is 2. So now it's simplified.
I thought we were trying to find the square root of 16.
The cubed root of 16.
Yeah, it's got to be even, ain't it?
What you mean even? No, that's not a perfect root. It's just like the square root of 50 is not an even square root. The cubed root of 16 is not an even cubed root.
I don't understand how you break it down. I don't understand that part.
So you're looking at powers of 3, and you're saying from this list, can I divide 16 by any of those numbers? 8, and what's left? So 8 and 2, and the third root of 8 is 2.
You just need 3 and 2.
Let's do another. Y'all seem to be confused on the, let's do this. Let's do another cube. The cubed root of, let's say, 135. I want you to simplify it.
What is that, 130?
135. And I'll write you a list of cubes here while you're looking. Have you found the one that goes in yet?
Yep.
Which one? from the right side of the list.
Oh,
Oh, 3.
Ah,
wait, what?
okay.
I understand what you're saying, bro.
These numbers.
27.
27. Yes. 27 times what gives you 135?
Wait, what? Wait, so you gotta take the numbers from the
You're
right.
looking for these numbers. Which one can you divide 135 by?
So essentially, we can just take the numbers
Five.
from the right side and divide until we get it.
Yes, that's exactly what you're going to do. We did the same with squares. You're going to do the same thing. So you're literally going to say, okay, 135 divided by 8. Nope, I get a decimal. 135 divided by 27. Oh, I get 5 when I do that. So 27 and 5. Okay. The third root of 27 is what?
7. 9.
Oh my goodness. What times itself 3 times gives you 27? 3.
5.
And the third root of 5 stays. Let's do another one.
I'll do one more.
Yeah, we did.
No, you're not good. You're not good. No.
I understand it. No, what I said that. They gotta do something.
Try this one. Cube root of 104. Hey. Oh. 8 and what?
8 and 16.
Close.
14.
13.
13. 8 and 13. Remember, you want the biggest number from this side that can divide in. So now I got 2 cubed root 13. Does that make sense? No?
Yes.
Yeah, that makes sense.
Alright, that's easy.
Alright.
Don't add
That's
nothing.
all we gotta do?
No, that's not all you gotta do, but I'm fixing to give you one that's got a bigger root than that. Oh my gosh, don't whine. It's okay.
It's already jammed, partner.
Hell yeah.
Much. You say you understand, show me you understand. Simplify that.
No, we
five. Chill out.
That's a 5. That's a. But what's the difference? We've done 2s.
Nobody
We've
does
done
it.
3s. What's
So let's go to the 5th power.
to the 5th power? So make a list of 5th powers. You're not going to have to go very far because they're going to get really big really fast. 2 to the 5th is 32. 3 to the 5th is what? 243. 4 to the 5th.
It's 6 something.
Why don't you put it on your calculator and see? What's 4 to the 5th, please, somebody?
1024.
1024. What about 5 to the 5th?
That's gotta be 5. No, that is 5. 3,120.
3125. So I don't have to go any further because I'm already bigger than my number. So of these numbers, can you divide 3072
Yeah,
but not 4, Bryce? The number on the right.
1024.
There you go. 1024 times what?
3.
1024 times 3. Good job.
If you give me one of them on the test, I'm not doing it.
You just did it. Why would you not do it on your test, but you'll do it in class? What's the 5th root of 1024? 4. You talk a tough game, but you'll do every problem on your test. You always do. Okay. Yes or no? The root tells us the list of powers we need to make, okay?
I mean, if you really wanted to on our test, you could put 20 in front of the square root.
Yes. But listen, how big's the number really going to get if you're to the 20th? What if I had the 4th root of 27 times the 4th root of 3? Now make a note here. Remember, this only works when the root is the same. But I can't split up 27 and I can't split up 3, but they're already split up. So maybe
You just times them together.
if I times them together, good job, Andrew. then maybe I can do something with it from there. So what is 27 times 3? 81. Now, looking at that, can you simplify it?
Yes.
How? Somebody said it. 3. It's just 3. It is 3. 3 times 3 times 3 times 3 is 81. Does that make sense? What if, instead of multiplying, I'm dividing?
Then you would divide the 250.
Divide them, exactly, divide them under that same radical. So 250 divided by 2 is 125. Can I simplify that? Sure. Yeah, divide. So if the root is the same,
But the root has to be the same, right?
yep, you can multiply or divide your bases. Okay, you can combine them, but only when the root is the same. I think that's down the hall. All right, let's try another. Simplify. I don't have a root there. What does that mean that the root is? 2. If it's not there, it's 2. It's a square root. Back to the original square roots that we used to talk about. So it's a 2.
So if
Yep.
it's not a square root, it's always a 2.
Yes.
Alright, I'll forget that.
What's 8 times 5? Put 400. That's right. Put a 0 on the end because it's times 50.
How are you getting that?
What's 8 times 50? 400.
I was trying to figure that out.
What time is it?
So now I need to see if I can simplify. Is that a perfect square?
But I thought it had a 2 on the outside.
Yeah, I hear yes. I hear no. What?
I thought it had a 2 on the outside. I just asked you that.
There you go.
Yeah, which would make that 2 and the other one 25.
If you want to split them up, first thing I'm going to do is put them together. And if you split them up first, that's not wrong, Bryce. So you did square root of 8, and then you did square root of 25, square root of 2. Is that right?
I guess, but.
Did you split the 8 up in 4 and 2?
Yeah, I split the 8 up. 8.
So 4 and 2.
No, I ain't do all that now.
Well, if you're going to split them up, that's how you got to split them up.
No, I just split them up and split 8 is 2 and the other one's 25. I ain't do all that extra. Right?
Did you get 2 square root of 2, 5 square root of 2?
Yep,
Okay. And you're multiplying, right?
yep.
2 times 5 is what?
20. 10.
Times, what's the square root of 2 times the square root of 2?
2. 20.
What's the square root of 400? You did a lot more work than we did. But that's fine. No, you're not confused. That's fine. If that's how you understand it, do it. That's fine.
I don't want to do it that way. I don't want to understand the other way. That's a long way.
How about one more and then we'll move on. What should I do?
Divide.
Call it the other.
What do you get when you divide?
Oh. You don't know what the answer is?
I really don't, but it's 8. At this point, that might be a perfect root, and it might not. I might have to split it up into two different ones, or it may give me a perfectly even answer, in which case this one does. You're right, Caleb, it's 2.
Wait, that was Andrew. I said 4.
Oh, you're right, Andrew.
I don't think it's.
I'm sorry. Yes or no?
Yes.
Okay. Multiplying, put them under the same radical, see if you can simplify it. Dividing, put them under the same radical, see. Remember, they have to be the same root, though. Okay. And we're breaking apart like we did with square roots.
So it comes
What'd you say,
out-
Sadie? I'm sorry. Then you can't simplify them. You leave them. Yours will all be the same root that I'm giving you. But
Is that what we working on today, is just that?
one more piece.
Man, I understood that.
You'll understand. Everybody understands this. This is easy. All right. So multiplying and dividing is harder than the adding or subtracting of the radicals because you can only add or subtract certain radicals. Okay. We have what we call like radicals. Just like when we have like terms, we have what we call like radicals. Like radicals means they have the same root and the same number under the radical. So, for example, now we'll have coefficients on these. Let's say I'm going to list out some radicals here, and I want you to find the ones that are like radicals. 2 cubed root of 5, negative 5 cubed root of 7, 2 fourth root of 5, negative 4 cubed root of 5. 2 of those are like radicals, the rest are not.
First one or last one?
The first one and the last one. First one and the last one are like radicals. The reason is because, so these are like radicals. The root here and the number under are the same. The number in front does not have to be the same, but those two things must be the same thing. Now, when you combine like radicals, you do it just like you do like terms. So if I had 2 times the cubed root of 5 plus 4 times the cubed root of 5, the only thing I combine is the number in front of the radicals. So what would this become?
So the only thing you combine is numbers.
6.
Yes.
So what are they different numbers? 5.
That's all you have to do.
You combine them. You can only combine the ones that have the same root and same radical. Okay?
And then you just add. or
This,
subtract.
you just add, it's kind of like terms when you're adding. If this was 2x plus 4x, it would be 6x.
Yeah.
The x is just the cubed root of 5. That's the only difference.
Alright,
Okay.
alright, but what if it's like 2
You don't
and
even have to explain
3 or
it.
4, and then the other one's 4 and 3 and 6?
Can't, then it's, you can't combine them. You leave
What
it.
do I do?
Leave it.
I don't have.
Literally, you leave it. That would be the answer, yeah. All right, now let me show you an example because sometimes you have to manipulate them a little bit so that you can see that they're actually like radicals. For example, and if there's nothing in front, then there's an imaginary 1. Let's say I have the cubed root of 5 plus the cubed root of 40. Those are not like radicals, do you agree?
Well, it's not the same.
The root's the same, but the number under the radical is not the same. So not like radicals. So what I want to do, I want to check to see if I can simplify any of them. In other words, break them up. Which one?
40.
The 40. Because this one, if I made a list of powers of 3, what goes into 40? 8 and 5. So this gets 8 and 5. What's the cubed root of 8? 2. So now I've got cubed root of 5 plus 2 cubed root of 5. Are they like radicals now?
Yeah.
Yes.
No,
Then
you got a 2 in there.
That's okay. That's the coefficient. This is like saying x plus 2x.
Oh, wait. So it ain't 2 plus 3/5.
It's 2 times. This is like a stop.
Yeah, I thought we put the plus in between.
You put the plus here. You're adding the radicals. Whenever you simplify this way, it's multiplied. So what do you get when you add these together?
2. 3/5.
If you had x plus 2x, what would you get? 3x. If I have cubed root of 5 plus 2 cubed root of 5, what do I get? 3
3 cubed.
cubed root of 5. This is 1 cubed root of 5. This is 2 cubed roots of 5. Okay, so if there's not anything there, then you put a 1. Still understand it? You told me not to do no more examples because you understood. Y'all good?
Yeah.
Sure?
Positive.